Okay guys, I'm going to run through another question here. It's the 2017 higher level question C3. One or two people had asked little bits about it, so I'm going to run through some of the stuff that would probably cause problems. Not the worst of a question, but there are a few tricky little bits like all the rest of them. So, first part of the question asking you to draw the given plan elevation of the 5 surfaces of the transition piece. So, don't think there's any issue with that. Scale 1 to 6, divide all the measurements by 6. Yeah, I don't think there's any problem with the setups. That's the initial setup of the question. Determine the dihedral angle between surface A and B. So, because A is quite a small surface, I'm going to keep A as the size it actually is. So, front elevation A, plan A. Surface B, I'm going to reduce it down to a smaller surface, so I've created my line here, 5, 6. On the surface B, brought point 6 back up here, joined it back up to 5, so that blue triangle is on surface B, which means it's going to be sitting at the same angle as surface B. Line of intersection, 5, 7 between the two surfaces, front elevation 5, 7. Okay, so the first thing we notice is that because neither of these lines are horizontal, neither of these lines are a true length. So the line of intersection is in true length in either front elevation or plan. So your first task, look perpendicular to the line of intersection, project out your view out here, bring out your points, step back 2 views, take your height from your elevation, you get true length over here, look along it, take your distances back to this view, get your dihedral angle. If you have any problems with dihedral angle still, go and look at the video I shared on dihedral angles. Okay, so next bit of the question, part C says determine the true length of the shortest diagonal on surface C. So surface C we know is sitting at an angle. I know that from the front elevation. Okay, there is the base edge of surface C, 1, 2. Because it's a horizontal line, that means 1, 2, just to put it in, is a true length in the plan. Okay, actually the line 4, 3, which is there, because it's horizontal up here, it's also a true length in the plan as well. I'm just going to mark that in. Don't need that information really at the moment, but we'll put it there anyway. So my shortest diagonal, there are 2 diagonals that can be drawn on surface C. One is from that corner 4 as far as 2, and one is from the corner 3 as far as 1. Obviously 3, 1 is shorter than 4, 2. So the diagonal I require is 3 as far as 1, which in the front elevation is 3 as far as 1. Okay, now they're asking me for the true length. So again, if I go back to my normal rules, this is not horizontal in front elevation, therefore it's not true length in plan. This is not horizontal in plan, therefore it's not true length in front elevation. Okay, so I'm going to take this line, which is obviously sitting at an angle like this, kind of hard to show on the camera, and we want to take it and rotate it back to horizontal in plan. Okay, so that's what I was trying to do. Just to explain this a little bit further for anyone who still finds that confusing, just going to flip to this little drawn one I prepared earlier. So if you look at, really what we're doing is this. If you take a cone, an inverted cone, okay, with its apex on the ground, there's the base or the top, depending on what you want to look at it. Plan of that is a circle. Okay, a cone is made up of elements which run from the apex as far as the circumference of the circle. Okay, so I've just drawn in 2 of those elements, 0, 1 and 0, 2. In the front elevation, 1 is there, 2 is there, there is 0, 1, there is 0, 2. Okay, you know by looking at this that that green line cannot be true length up here because we're looking at it at an angle here. There's my arrows to show the angle that I'm looking at this at. Okay, so that is now a true length. This one also, because it's at an angle, is not true length up here. Okay, so nearly by default at this stage you would know that the only line that can be, or lines that can be true length on this, are the lines out at the edge. Okay, why is that the case? Because if I go from the center with a horizontal line out as far as here, or if I go from the center with a horizontal line out as far as here, that line is going to be a true length in front elevation. So if I draw that in orange, bring that up, let's say this is 0, 3, 3 is right up here, there is 0, 3. 0, 3 is a true length line. The same would also be true if I did a line over on this side. Let's say it's 0, 4, 4 would be up here, 4 joins back to 0, that would also be true length, but note that they're on a horizontal line. Basically, if you think of it as that green line, look at what has happened. It has gone from sitting at the back of the object, okay, and we've rotated that element around until it gets as far as here, to horizontal. So it's like 0, 1 has rotated as far as the position 0, 3. But look how it's moved in front elevation. It has moved horizontally. Okay, so that's the important thing. 1 hasn't changed in height, hasn't gone up or down, it has gone straight out as far as 3. Okay, so if you even take your pencil and do that and look at it yourself, you're rotating those lines in a conical shape. The top of the pencil is moving horizontally, it's not going up or down. Okay, so rotation plan to horizontal, move horizontally in front elevation. So if I go back to the previous drawing and apply that rule to find the true length, and this is one way of finding the true length. There's a diagonal. I'm going to move that diagonal onto a horizontal line. Okay, so grab the compass. Set it 3, so again I'm rotating that onto horizontal. So 3 has moved out as far as there. Bring it to the front elevation. As I said, in the front elevation, 3 is going to move straight across as far as here. Therefore, the true length of that line, it hasn't moved, it's rotated from point 1, so point 1 hasn't gone any place, so point 1 has stayed in the same place. So that line there, which is the front elevation of the rotated line, that line is now a true length line. Okay, so that is the true length of the line, of the diagonal line 1, 3, the shortest diagonal on the surface C. Okay, so you've been asked to use, it says use triangulation or otherwise determine the true shape of the surface C and the rest of the development. You can take that length, so we know the true length of this edge is that distance there. Okay, I think the easiest way to do it is to take the surface C and fold it out flat. Okay, using this true length line as a hinge. Okay, and I know that if I use that true length line as a hinge, that all these other points will move at 90 degrees to it. So if I go and take point 3, bring it out that way 90 degrees to the hinge edge, take point 4, bring it out that way 90 degrees to the hinge edge. Okay, so 90 degrees to that. This point 3 is going to have moved out here someplace, and I know it's true length because remember, when we're getting a true shape, and a development is essentially a true shape, I can take that distance for point 3, which is my, or 1, 3, which is my true length. Go down here and mark it from 1, and mark it out onto the line from which 3 has come. Okay, so that's where that has actually moved to now. All right, join it back in the same way. Sorry, 3 joins back to 2, so I can join that way. Okay, 3, 4 is going to stay parallel to 3, 4. So if we get the set squares out of the way. So 3, 4 will stay parallel like that. And then 4 joins back to 1. Okay, my true length line, so the true length of the shortest diagonal is right there. Okay, that one is the same as this one up here. Okay, I'm going to do a separate video showing the other way I use to find this shape here and to find that true length. To me, I think it's a little bit easier. I've taken an edge view look in this direction. But just to try and get this video some sort of a size where I can upload it, I'm going to stop it now. I'm going to send on the drawings of this as well, so if you have any questions, please ask. Okay guys, thank you.